This week we are starting our third unit looking at the atom, and our study is going to start by looking at what is inside of the atom, or we call those subatomic particles. And today we're just going to focus on the history of how we came to kind of figure out what's inside of an atom and the function for the different parts of an atom. So let's start off by just kind of summarizing what each of these different particles in the atom is responsible for, what its charge is, what its mass is, and how it relates to an atom. So a proton is positively charged, and we will usually show a proton with a plus sign if we're drawing it. And it determines the identity of an atom. If you have a different number of protons, now you have a different identity or a different element that you're working with. And that comes straight from the periodic table. What we call the atomic number. Atomic number is the number of protons, and that is how elements are arranged on the periodic table, by atomic number, and that is the top number of an element squared. Protons also have a mass of 1 atomic unit, and so that is just to say, or atomic mass unit. It's not grams because they're so tiny. So instead we use atomic mass units, or AMU. So if you ever see AMU, that's referring to our tiny units of mass of particles. The proton was discovered by a guy named J.J. Thomson through an experiment called the Cathode Ray Experiment, which is pictured on the left side of our example 1. So let's go ahead and talk about this while we're talking about J.J. Thomson. So if you look at the picture in example 1 on the left, this is the Cathode Ray Experiment. And the example asks us to identify the experiment, label its parts, describe its conclusions, and draw the resulting atomic model. The experiment name of this picture is the Cathode Ray Experiment. And I just told you the scientist who is responsible for this experiment is J.J. Thomson. And through this experiment, he discovered charged particles, specifically the proton and the electron. So parts to label here, we have this beam that is shooting through the cathode ray. This is our electron beam. And at the time, he didn't know it was electrons. He just knew it was a particle that was inside of an atom. And then in this cathode ray, there are 2 different poles. There's the positive pole, so that's this guy. Positive pole. And the negative pole. Our charge here. Okay, so we have our positive and our negative poles. The expected path is this dotted line right here. It was supposed to just go straight through because atoms are neutral in charge unless they are ionized, meaning they have extra or less electrons. Well, what actually happened was this electron beam bent towards the positive pole. So this is the actual path. And the information or conclusions that were drawn from this bend is that negative particles attract towards positive things. Think like a magnet. So when we saw this bend, or J.J. Thomson saw this bend, he then concluded that there are charged particles inside of atoms. It's not just an indivisible, ball. So there are charged particles in atoms. And specifically, he discovered electrons because it was attracted to the positive pole, and opposites attract. So he called them electrons and said that they are negative. And because atoms are positive, that also led to the discovery of protons, which would be positive. So those are the conclusions he made. His atomic model is called the plum pudding model. And it looks just like a ball with positives and negatives throughout it. I would probably call this the chocolate chip cookie model if I were the one coming up with it. Each of the particles kind of representing a chocolate chip. But plum pudding is a dessert in Europe, which is where he comes from. So plum pudding model it is. So there's experiment 1, and this led to the discovery of both the proton and the electron. One other piece of information that J.J. Thomson did not know, but we're going to add it here, is that the proton is located in the nucleus. And that is part of the other experiment by Ernest Rutherford. We will get to that in a moment, but let's first focus on the electron, since that's also part of the cathode ray experiment. We talked a little bit about their charge being negative, so let's start there. These are negatively charged particles, and they're really, really, really tiny. So they do not have mass, and they actually determine charge in an atom. Protons determine identity, electrons determine charge. If the protons equals the electrons, then it's neutral. If they do not, then we have charge. So you can find that by subtracting protons minus electrons. Because a neutral atom has equal protons and electrons. When the positive and the negative balance out, the charge is 0. It has negligible mass, meaning 0 negligible. There we go. Meaning it has 0 atomic mass units. If we're ever talking about our units, because they are so tiny, they are negligible. And again, this was discovered by J.J. Thomson in the cathode ray experiment. His experiment led to the discovery of both protons and electrons, because, like we said, the beam pulled towards the positive pole, showing there was a charged particle, which was negative, but because atoms are neutral, there also had to be positive particles inside of an atom to balance it out. The electron is not located in the nucleus. It is located in what we call the electron cloud outside of the nucleus. Now, the neutron was the hardest particle to be discovered because it is neutrally charged. And a lot of the tests that they did back in the day had to do with magnetism. And so something's neutrally charged, that's really hard to figure out if it exists because there's going to be no pull from it. The neutron determines both the mass and stability of an atom. And when I say mass, this is going to be important for a word we call isotopes. Okay, so an isotope means that it's the same element, but it has a different mass, which would imply that we have the same number of protons for both atoms, but our neutrons are going to be different, and this is because it also has a mass of 1 atomic mass unit. So our mass of the atom will be equal to protons plus neutrons. That's going to be our mass for any given atom. That'll be helpful when we're looking at calculating the mass number. Like I said before, this was the most difficult to discover because it is neutral, it does not have charge. And this too is located in the nucleus along with protons. Protons and neutrons are located in the nucleus. So let's talk a little bit about the nucleus in our second experiment here. This is called the gold foil experiment, and it was conducted by Ernest Rutherford. And in this experiment, he had a source set up that emitted some little particles through a little laser, and then this circular kind of semicircle thing is the detector. And in the middle we had some gold foil. And what was expected was, again, the laser was supposed to just go straight through. But what ended up happening was the actual path bounced back. And so what that told us was inside of an atom there's a dense positively charged nucleus that caused the positive particles to bounce off because same charges will repel one another, and that's what happened when it bounced back. So the conclusion is there is a dense central positively charged nucleus in atoms. So he added to the plum pudding model, this is called the nuclear model, a nucleus. So now we have all the positive stuff in the center and then the electrons randomly around it. And this is close to the actual model of the atom, but we had some more developments that show us a little bit more about the placement of the electrons. Let's go ahead and define nucleus. We just talked about it. It's a dense, positively charged mass in the center of an atom. So our nucleus is positive, and it contains neutrons and protons. So it has all the mass of the atom. And then the electrons fly around outside of it. And this was discovered by Ernest Rutherford in the gold foil experiment. Okay, so there's our kind of history. Now some notation. We have two ways that we can write atoms information. One is through the isotope name, where you will write the isotope name or the name of the element followed by a dash and the mass. So element name dash mass. So for example, if I have an isotope name, maybe it'll be hydrogen with a mass of 2. Hydrogen 2. There's my isotope name. The nuclear symbol for any element for their information is written with the charge in the top right corner, the mass in the top left, atomic number in the bottom left, and the element symbol. So for hydrogen 2, I would have hydrogen, we'll say it's neutral, it would have its atomic number and its mass number. There's a nuclear symbol. We're going to do some practice problems at the bottom with the example in another video.